Okay, so today we'll look at how to find the independent term of x in a binomial function. Alright, so this one is a quick revision, but it's an effective one which will make you understand how to work out the independent term of x in a binomial function. Alright, so this is an examination question which I got. So now the question says, find the term independent of x in the expansion of open the brackets x minus 1 over 3x squared, close the bracket, the power 15. So now how do we work out such? Okay, so the best way to work out such is to identify that they want in the expansion. So the expansion they want a term which is independent of x. So now when we refer to the independent term of x, what we mean is that we need to find that term that will have x the power 0, because anything raised to the power 0 will be what? Will be 1. So that term will just have the coefficient of numbers and there won't be any variable of what? Of x. Now, how are we supposed to work out such? We know that we need to identify that you have been given. So in this function, what we only have, it is n, which is 15. Then we don't have the position or the term r. So r tells us the position at which the term is of that. Now, in this expansion, which when we expand, we're going to have 16 terms. Now, in that 16 terms, when we expand this, we are not sure of where the position which will give us this value. So now what we're supposed to do now is to find this what? This r. So how can we find this r? We know that using the binomial theorem, which we know that if you have a term a plus b raised to the power n, this term should give us summation of what? N, then r, where we have the coefficient of a binomial which is n factorial, n minus r factorial, then we also have what? R factorial, then a to the power n minus r, and b to the power r. So this is what we call a binomial theorem, which we can use to expand a binomial with what? With two terms. So now how can we use this one to apply to find the independent term of x? So now we need to find the value of what? R, for us to work out that one. So now we need to apply the formula. So we have the n, which we can say n it's 15, then the combine, we summing up with what? With r. We don't know what r is, the position, but we have the term they have given us, the term which is x, the first term there. So it is x raised to the power 15 minus r. So now we need to find the b term, which is this one, which is negative 1 over 3x squared. This o term is raised to the power r, which we don't know. So whenever we expand this term, what we should get is x the power 0, because x the power 0, it's the term that has independent term of x. Okay, so now what are we supposed to do is to find r. So from the basic principle of indices, which we know how to apply indices, what we're going to do is to reverse this one into a negative index, which is 3x squared, so that we can have x and x as the numbers without fractions. Okay, so this will be now 15 combined r, then x 15 minus r. So reversing this one, it will be negative 1 times 3x negative 2 multiplied by r there, r, then is equals to x to the power 0. Hope we are following here. Then what we can do now is we can compare with the coefficient of x by applying laws of indices. We know that these terms are multiplying. So we have x there and we have x there, which is what? Which is multiplying. So we can extract these terms, which will be x 15 minus r. Then we have also x negative 2r. This should give us what? X to the power r. So I hope you have seen that we have just formed a simple equation which can help us actually to find r. So what we are going to do now, it is to use the laws of indices. When bases are the same here, we can add the powers. So meaning you can have 15 minus r minus 2r should be equal to 0, which will give us 15 minus 3r should be equal to what? To 0. Finding r, we can add both sides by what? 3r. Even here we can add 3r. So meaning this and this will give us 15, because 3r and minus 3r we get 0. So 15 is equals to, then 0 to 3r we get 3r. Then finding the r, we just divide both sides by what? By the coefficient of r, which is 3. then there r will be what? Will be 5. So the position of 5, that is the term where we are getting what? The independent term of x. Now we go back to the equation which we have stated here. We just have to do what? To do a simple substitution. So this will be now 15 combine 5, since we have found r it's 5, then x raised to the power what? X raised to the power 15 minus 5. I hope we are seeing 15 minus 5. Then we have this second term, which is negative 1 over 3, then x squared. So this term is also raised to the power 5. Also on top there, it's power 5, because it's everything raised to the power r, which is equals to, we have to find that term now. So now, with a simple calculation, we know we have to have a calculator there. I hope you know how to use a calculator. So now what you have to do is just to punch 15. Then on the calculator, there is this function which is NCR. It's a combination. So you punch there, then you also punch the number 5. So this means 15 combined 5, we get 3003. So we have to write 3003. So 3000 there and 3. Then we know 15 minus 5, it's 10. So this will give us x to the power 10. Alright, let me write nicely there. So this will be now 3000, then x, we know that 15 minus 5, it is 10. Okay, then this one, we know that 5, it's odd number. So when you're raising something to any number to an odd number, especially a negative, it becomes what? It becomes negative. So we're going to have negative 1 over, then x, which is times 2 there, you can see. So meaning that we're going to have x, which is 10, because 2 times 5, it's 10. Then 3 raised to the power 5. So we just have to punch on the calculator that one. So it is 3 raised to the power 5. So this is giving us 243. So we do 243 down there. So we have seen that we have 10 there and 10 there, which can cancel. So finally, we can say that if we multiply this, we're going to have negative 3003, then over 243. So if you want, you can just leave the answer like this. If you want, you can reduce it, but the best, even here it is fine, you're going to get what? Or the max. So this is the answer which I've actually worked out. So this is a simple question which you can try out, and when try out, you can send the solution, then I can check through. But basically, this is a way we are supposed to work it out. Thank you very much for watching.